Section 6.4 is on rectangles. The definition of a rectangle is a parallelogram with 4 right angles. So the way we abbreviate it is we draw a little rectangle, and notice it's not slanty like we did for the parallelogram. And again, we name it by its 4 vertices, and we can start with any vertex and either go clockwise or counterclockwise, but you have to go around. Okay? So according to the definition of rectangle, angles A, B, C, and D are all right angles, because this is a parallelogram that has 4 right angles. Now, since a rectangle is a parallelogram, all of those properties and all of those theorems about parallelograms apply. So, in a rectangle, opposite sides are parallel to each other. AB is parallel to CD, and AD is parallel to BC. Also, opposite sides are congruent to each other. AB is congruent to CD, and AD is congruent to BC. Opposite angles are congruent, well, and that's kind of obvious because all of the angles are the same. They're all 90 degrees. Angle A is congruent to angle C, angle B is congruent to angle D. Consecutive angles are supplementary. Angles A and B are supplementary, B and C are supplementary, C and D, D and A, and that's also kind of obvious since they're all 90-degree angles. Any two 90-degree angles add up to 180. And the diagonals bisect each other. So I don't think I had diagonals in this picture here, but if we were to draw BD and AC, they would intersect here. I would call it point E, and they would be, so BE would be the same as ED, AE would be the same as AC, EC. Okay. And there's one additional quality of a rectangle that was not true in a parallelogram, is that the diagonals of a rectangle are congruent. So diagonal AC is congruent to triangle BD, and actually this is kind of fun to prove using congruent triangles. You would show that triangle ADC is congruent to triangle BCD, and then using CPCTC, you would know that those diagonals are congruent. But that's one thing that distinguishes, besides the right angles, that distinguishes a rectangle from a parallelogram. So using all of these qualities of rectangles, let's do a couple examples. So here we have rectangle ABCD. Number 1 says if AE equals 3x minus 5 and BD equals 5x plus 1, find the length of AC. Well, I know that in a rectangle, the diagonals are congruent, and I know that they bisect each other, so I know that all 4 of these little pieces here are congruent to each other. So AE is the same as EC, BE, and ED. Now, so they give me an algebraic expression for AE, but then they give me one for BD. Well, it looks to me that BD is going to be twice as long as AE. So I can say 2 times AE is equal to BD. Let's look at that again. AE is half of a diagonal, and BD is a whole diagonal. And I know the diagonals are congruent to each other, so 2 AEs is going to equal 1 BD. So 2 times 3x minus 5 equals 5x plus 1. 6x minus 10 equals 5x plus 1. So x equals 11. But then I was asked to find the length of AC. Well, AC is actually equal to BD, so I could go ahead and do that. Plug it into there. So 5x plus 1, or 5 times 11 plus 1, or AC is equal to 56 units. Another way I could have done that is I could have said AC is equal to 2 times AE and done it that way, but I will get the same thing either way. Example number 2. If the measure of angle BCA is 2x minus 3 and the measure of angle ACD is x plus 12, find x. Let's go ahead and mark these on the picture. Angle BCA is this angle right here, and angle ACD is this angle right here. Okay, those angles are right next to each other, and because I know that large angle C, angle BCD, is a right angle, I know that those two have to add up to 90. So 2x minus 3 plus x plus 12 equals 90. 3x plus 9 equals 90. 3x equals 81, or x equals 27. So in this problem I was given algebraic expressions for this purple angle here and then for this purple angle down here, and I know that the two of those have to add up to 90 because every angle of a rectangle is a right angle. And example number 3 here, I'm going to go ahead and mark these again. If the measure of angle DBC, so here's angle DBC, is 8x plus 4, and the measure of angle ACD, that's this one right here, is 3x minus 2, find x. Well, let's see, it's a little, those two aren't next to each other, but I do know, there is some interesting stuff that I do know about this, that all of these diagonals are congruent to each other. Okay, so if you notice, or the half diagonals are congruent to each other, so you'll notice that this rectangle is really made up of 4 isosceles triangles. This triangle right here on the right is an isosceles triangle, and because I know these sides are congruent to each other, those two triangles are actually going to be congruent to each other. And I also have isosceles triangles top and bottom, and because AB is congruent to CD, I know that these two triangles are going to be congruent to each other. Well, does that help any? I think it does, actually, because in this triangle right here, if these two legs of the isosceles triangle are congruent, then these two angles are going to be congruent to each other. So let me see if I can go ahead and write stuff in here. So this angle here, angle DBC, was 8x plus 4, and so is this one as well, 8x plus 4, DBC, yeah. So because that's an isosceles triangle, and the isosceles triangle theorem says that those two angles are congruent, and then this angle right here was 3x minus 2, and now I notice that these two angles make up angle BCD, which is a right angle, so those two have to add up to 90 degrees. So 8x plus 4 plus 3x minus 2 equals 90 degrees, or 11x plus 2 equals 90, 11x equals 88, and x equals 8. Okay, so when you see the diagonals drawn on a rectangle, it's good to think isosceles triangles, and go ahead and mark everything that you know that's congruent to each other. It might help you solve the problem. Okay, this example says determine whether the given coordinates are the vertices of a rectangle and use the indicated formula. So here I have coordinates of the vertices of a quadrilateral, and I need to determine whether this is a rectangle, and we're not going to graph it and look at the picture of it. I need to use the slope formula. Now remember, what slope does is it gives me the slope of a line, but it can also tell me whether or not two lines are parallel to each other, in which case they would have the same slope, or if two lines are perpendicular to each other, in which case their slopes are going to be opposite reciprocals. So one important thing about a rectangle is that it has 4 right angles. So in a rectangle, opposites or consecutive sides need to be perpendicular to each other. So I'm going to use the slope formula to figure out if consecutive sides are perpendicular. Are consecutive sides perpendicular to each other? In other words, is the slope of the top the opposite reciprocal of the slope of each side? Is the slope of the bottom the opposite reciprocal of the slope of each side? So I need to find the slope of each side. So the slope of AB, the slope of, actually I'm going to do a little sketch here just to help me see this a little bit. So A, B, C, and D. So the slope of AB, the slope of BC, the slope of CD, and the slope of AD. Sorry about that. Okay, now this is where it would be really helpful again to have the program for the slope formula in your calculator, because you can just start punching in the numbers. And when I do that, I find that the slope of AB is 2/5. Leave it as a fraction. Don't do the decimal. It's easier to see opposite reciprocals. The slope of BC is -2. The slope of CD is 3/5. And the slope of AD is -5/2. So if you'd like, you can go ahead and actually put those on the diagram here. So the slope of AB is 2/5. The slope of BC is -2. And right away I can stop right there because those are not opposite reciprocals of each other. 2/5 is not the opposite reciprocal of -2. Okay? CD is, the slope of that is 3/5, and actually those two would have to have the same slope, okay, in order to be a parallelogram, which is a condition for being a rectangle. And then the slope of AD is -5/2, and actually AB and AD are opposite reciprocals of each other, so these two sides would be perpendicular to each other, but none of the others are. So no, this is not a rectangle because opposite sides are not, or consecutive sides are not perpendicular to each other. Consecutive sides are not perpendicular. And I'll make up my own little diagram here for not perpendicular to each other. Okay, so I would need to see your work. I don't need to see that you've actually worked out the slope formula, but I need to see the slope of each side and then an explanation of why it is or is not a rectangle. And then let's take a look at our last example here. Again, we're given the coordinates of the vertices of a quadrilateral, and we're told to use the distance formula. Now, it's not really enough to show that like the top and the bottom are the same length and the left and right sides are the same length, because that is also true of a parallelogram. I need to come up with what is distinctive about a rectangle, because I'm being asked, are these the vertices of a rectangle? And one unique thing about a rectangle is that the diagonals are congruent to each other. So I'm going to use the distance formula to figure out if the diagonals are congruent to each other. And for this, I'm going to actually draw a little picture. Again, I find it helpful just to kind of see things. So A, B, C, and D. And since I'm going to be checking the diagonals, I do want to draw those in. Okay, so I need to find the length of AC, which is this diagonal here, and then the length of BD. And if my two diagonals are congruent to each other, then this is a rectangle. So again, using the distance formula, hopefully you have that program in your calculator and you can just punch in the numbers. I find that the length of AC is the square root of 89 units, as is the length of BD, the square root of 89 units. So the diagonals are congruent. Therefore, this is a rectangle. Okay? So if you're being asked, I think that's the last problem, yeah. So if you're being asked to use the distance formula to figure out if it's a rectangle, check and see that the diagonals are congruent to each other. If you're asked to use the slope formula, you'll need to show that consecutive sides are perpendicular. The consecutive sides have slopes that are opposite reciprocals of each other.